What's up guys? Welcome to this video, and we're going to be learning about the Raspberry Pi operating system today, navigating the operating system. Now you don't necessarily need an operating system in order to use the Raspberry Pi. It could go bare metal, but for the applications we're developing, using an operating system is kind of what you want to do based on the packages and facilities that will be available to you on your Raspberry Pi. Our Raspberry Pi operating system is Unix based, and what that means is that it is POSIX compliant, and POSIX ensures that commands will work the same way across all systems. So if you have another Linux distribution like Ubuntu, you have macOS, you have BSD, you could be sure that the commands will work across the board. So you'll want to open up your terminal and you'll want to have it full screen. And the first command I want to teach you is the ls command. And what this ls command does, it simply lists all the files and folders in the current directory that you have. Now, if you want to get some help about any command, you just have to do ls --help. And what that will do is it will tell us, some of the arguments we could put after the command in order to get our programs running or whatever, we want to do the command. You also have the manual pages. You could type man ls and you'll see the manual pages and I see the name, synopsis, description. These are ways that you could get help for any commands at any point in time. So you press Q to quit. What I want to go over is looking at some commands to really get your fingers moving. So first thing you could do, you could put pwd. That prints our working directory, which is the current directory we are in. If you want to clear the screen, you could type clear. That clears our screen. Right now, ls, we see our current folders. If you want to change the directory, we can type cd, right, and the name of the directory. So we can say cd, let's go desktop. And we are now in our desktop. Now, if you want to go back up a level, we can type cd and 2 dots, type ls, and you see we are right back where we started. This is our home. And if you want to go home at any time, you can use this, this tilde character, this kind of squiggly, squiggly command here, cd, and that will take you home, right? And if you look, you'll see, home will be this here. You'll see it appended to all the commands on your terminal on the prompt. Right now, one of the things that I want to look at is working with files. So to create a folder, you'll say mkdir, that's one make directory. I'll create a folder called my folder. That folder is created. We want to create a file, we'll say touch readme .txt, and that creates a text file named readme. Linux has a lot of built-in text editors, Unix, and one of them is Nano. So you could say nano readme.txt. And in my case, it was existing. So we could type the text we want in this, and this is a regular text file that we could edit. Now you type command X to exit. If you have stuff to save the access here before. Right now, sometimes according to how you want to manipulate this file, it is the sudo command. So you do sudo readme.txt. Might ask you for a password. In my case, it's not configured, but you'll usually enter a root password. Oh, sorry, that's supposed to be sudo nano, right? Because we already text editor, and it's open. So we'll add some more text. So we have text here, and we'll add some more text. type here Control S, Control X. And if we want to see the contents of the file, so we type ls, we see the command, we see the files here. And if you want to see what's inside that file, we'll type cat readme.txt, and I can see the contents of the file. If you want to delete that file, we'll say rm readme.txt, and the file will be removed. So we do a ls, and you see the file is no longer there. If you want to remove the folder, we'll do rm-r. This -r is needed because you take a kind of recursive erase feature when removing folders, and you remove my folder. Now, if you don't like typing this stuff a lot, you can say tab, and it will do an auto-completion. So if you type my, hit tab, you see it auto-completes the rest of the stuff that you need, and that's really useful. Right? So remove my folder, and my type ls, and you see my folder is gone. It's no longer there. Right? Now, there's other ways we can list stuff. So we have been using the regular ls command. That's regular list, but there's also the long listing. So if we do ls/l, we get our long list. And you see there's a lot more information. You're seeing sizes, you're seeing permissions for reading, writing, that kind of thing. You're seeing user information and the file. Now, on Unix systems, if you're familiar with Mac OS or used Linux before, there are hidden files, and these are files that you don't really see when you do regular listing, and the way you see those hidden files is you'll type ls/la, and all these hidden files have a dot in the front, and what this dot does is it specifies that it is a hidden file. But there's another option. So you look at the file sizes, how they are given here, and we see that it's not really readable. So you can put them in the human readable sizes. If you do ls dash, you say lh, you'll get the human readable sizes for the files that, and folders that you have in your current directory. The command I want to cover is what is known as the grep command. And grep is for using general expressions. So, for example, let's create a file. So we say touch. Let's say text.txt. It will be created, and we say nano text.txt. We'll enter into that file. So let's put some text in that file. We'll call text. Control S and Control X. Right? And it's there. So you can say cat text.txt, and we see that it has the text we have. So ls, we see where we are. Now if you type grep and we look for text and use a wildcard, this asterisk here is a wildcard, so it means everything. We see that the text.txt, you see the content, you see it found the text, and you see it also tried to go to directories and realize that it's directories. You could also have said, grep text, and then our file is text.txt, and it would have also located text there. Right? Now, something else we can do is we need to start looking at this user permissions. So user permissions is really important. So type ls-l, get a long listing, and we see these user permissions here. Now let me explain what that is about. So if we look at the files in directory, you'll see things like d, r, w, xr, and you'll be wondering what those are. So I'll actually use, using tight VNC, I can actually use the Raspberry Pi mouse. Hopefully it is recording it's recording both mouses. So So you'll see D, R, W, X, R, and those are just file permissions and directories. So anytime you see D means that it's a directory. When you see this kind of dash, it means that it's a regular file. Right, so if you look at the text file we created, you'll see dash. And if you look at, for example, downloads, desktop, bookshelf, music, you'll see D. You can also see an L, which is for a link, right? Think of it like a hypertext link. And you also see this D, R, W, X, R, X, R. Now, at first, this is very unintuitive, but if you look at how it's classed, it actually classed into different sections, right? And it's groups of 3. So the first 3 will be for, so you have a directory. The first 3 file permissions tell you that's the user file permissions. The second 3 will be the group file permissions, and then the third 3 will be others, because in Unix and Linux, you could assign groups to create users and stuff like that. Now, for the scope of this tutorial, we are just really be concentrating on navigating the command line, using the command line so we could build AI applications. We're not really focusing on groups and users and stuff, which is more administrative access, but there are a lot of resources you could do the administrative access with if you need it. And what this R is for, this R is for read, W is for write, and X is for execute. That's all this is. So let's look at the txt. So if we look at the text.txt, we see that it's a file, right? The user has the option to read, write, but we can't execute, right? We see that groups, user groups, others, all they could do is be able to read the file. So sometimes you might want to give other person access to the file. You might need to execute the file, think if the file is a script, or the file is, some type of program we want to run or something, you need to give it executable permissions. So the quickest way we could change the execution status of the file is we could say ch mod, right? Kind of like change mode. And we go with +x, right? So we want to add execution permissions to text.txt. We type ls and check the long format. And if we look at txt, we see that we got execution permissions, and the file is also now green. When time you listen and see this dot of green, that means that the file is executable, right? We're able to run it. Now we could also remove permissions. So we could say ch mod, right, -r. So you could remove read permissions from the file and remove read permissions from text.txt. Type ls. We see the file there, but let's say do the long format so we could see for sure, right? We see we no longer have read permissions. So if we try nano and we say text.txt, right? Error reading the file permission denied because no one has read permissions for this file, right? We Control X, we could reassign the read permissions. So we say ch mod, we have +r, and the file is text, tab it out, right? And if we go up and do the nano again, we see we could read the text file now. So that's very important. What you should know about these permissions is that you could also you have the ability to change by users and groups and stuff like that, but we won't be dealing with that. What I want you all to know is there's something called the octal mode, right? And the octal mode is something like change mode, and you'll see 777. Now 777 is all permissions. And the way this works is 1 means to execute, 2 is to write, and 4 is read. And according to how we add these numbers, so if we say for This will be our users. This will be permissions for the groups and the permissions for others. So instead of having to type out, so instead of 777, you should do something like u is equal to, let's say, rwx. We could say g, and most no spaces, g is equal to rw, and let's say others is equal to rwx. Right, so we could have done it like that, or we could just have used the octal mode, and 777 is all permissions, and you see that a lot. So right now we look at text.txt, and if we see chmod 777, and we say text, right, text.txt, if we do the long listing again, we'll see that all permissions are set across all the different various users, groups, and others, right? So I also want to cover environment variables, because this is something you might have to set a few times. So the way we do this is with the bash rc file. So if we look, we have our ls, we have the long format here, and we see this .bash rc. Now we can edit this bash rc. So let's say nano dot bash rc, and we see all of the stuff that executes every time a new shell starts. So every time a new shell starts, all these environment variables could be set. Now we could set our own. We could say something like echo and new shell row. So we start a new shell, right? And Control S, Control X. Now if we start a new shell, a new terminal, we see it's automatically executed there, right? So we'll change our back because we don't want to keep that. So nano bash rc. Let's erase the environment variable we just set. And if we start a new shell again now, we see it's no longer showing up. Alright? So this has been getting very large, very clear. So notice the environment variables, you can navigate, you could change files, folders, you could do executables. And I think the last thing I want to show you is how you install packages. So to install packages, you'll say sudo apt install and the package name. So our common package is tree. So we'll install tree. And if we type tree, here it gives us list all stuff with the tree command like this. And we can also look at processes. So if you want to see how much RAM, how much memory is being used, you can type htop, and you kind of get an idea of what's running, what's not running, what's executing, what's not executing on your device, and you can actually kill it. You can actually start to kill processes, with the kill/9, and then you could kill your processes. A lot of tutorials on using top and stuff, I wouldn't go into it, but you could kind of get the idea of processes running with top, and how much memory you have, what the swap looking like, and what your cores are doing and stuff like that. So you kind of want to learn, there are a lot of tutorials out there. I don't need to cover top too much tutorials out there for that, but you could, take a look at some htop tutorials and kind of go through top. So this is all you really need to know to be able to navigate your Raspberry Pi, terminal, and take some time, try creating folders, doing permissions. It's just like your regular GUI system you're accustomed to. It's just you have to type commands to go move around and start clicking. And over time, you'll see it becomes very efficient to use the keyboard instead of having to, use your mouse to click around. So that's it, guys. Thanks for watching. Thanks for joining me. In the next video, we'll actually start getting into some AI stuff. We'll cover some machine learning, move on to deep learning, stuff like that, the traditional stuff. And then we'll move on to, looking at running LLMs and stuff like that locally, and we'll look at some projects. Thanks for watching. Be sure to like, share, and subscribe to my channel.